Hi everyone and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 3 of seminar 4 in the University of Debrecen, and the biostatistics subject, which will be mainly focusing on the Poisson's distribution, solving the problems. So in this problem, albinism is a rare recessive inherited disorder. It is estimated that the probability that someone suffers from albinism is 1 over 20,000. So if we can see here, we can notice the probability is very, very, very small. So it's not 1 of 10,000, it is half of 10,000. So it is very small. So the first thing must be trigged in our mind. This is Poisson distribution, because Poisson distribution means very, very minor and it is less likely to happen. Low probability, less probability to happen. But huge population. So let us look at the population here. If we have a sample of big size or small size, if both of them are happening, probability is very small and sample is very big size, so automatically we'll know that we are going to use Poisson distribution equation. So the probability here will be 1 over 20,000. Let us assume that we investigate the population of 10,000 people. So it is very big population. 10,000. So N equals 10,000. P equals 1 over 20,000, which equals 5 times 10 of power minus 5. So be careful when we write the numbers here. Don't forget to add. Don't forget and add any zeros or forget one of the zeros. So all the answers will be incorrect. So be careful when you copy the numbers from here to the calculator. So my first question. Can I use Poisson? Yes, I can use Poisson because the probability is very, very small and the number also is very large. So if I multiply n by p, I'll get a reasonable number. N by p, what it was called? It's called the mean. So my mean was not mu or x bar. In Poisson case, it's called lambda. And this lambda called NP. It's called the coefficient of Poisson distribution, or the property of Poisson distribution, or the mean of Poisson distribution. So I have to multiply them together to get the lambda. So lambda will be equaling 5 times 10 of power minus 5 times 10 of power 4, which is 10,000. So this will cancel with this, will end up with 0.05. So now I have lambda equal 0.5. I have P equal, this number, small number. I have n equals 10,000. So once I get lambda, I don't need all these informations. Only what I want is lambda. I forget about this very high population or very small probability. I forget about them. Even I can erase them. So I just needed them to get lambda. So lambda equals 0.5. There are second parameter only which I'm looking at, which is, so if you remember, in the binomial we will having P, we'll have Q, we'll have N, and we'll have K. 4 parameters. I should have them. P, and from P I can get Q. Then I have N and K, so I can use the binomial. But here in this Poisson, the beauty of it that I need two things: lambda, which I calculate from NP, lambda equals NP, and I need K. Only these are the only two things. So what is the probability? He needs exactly 3. So K equals exactly 3. That's it. Then I write the formula or the rule of Poisson law and I calculate it. So what Poisson rule says that the probability for K equals how many? 3. For K equals 3, the probability equals lambda on the denominator and then E of minus lambda before forgetting it. And the lambda of power K, and what here K. This is the way I remember it actually, but you have your own way of how to remember it. So I said lambda divided, and here I put E of power minus lambda. Don't forget minus or negative lambda. Then I put K factorial and the K here. And the above. This is the way I used to remember this Poisson, but it's up to you. So you have lambda. You can calculate it here, okay? So the probability of k equals 3 equals lambda equals 0.5, 0.5, and k equals power 3, okay, divided 3 factorial e power minus 0.5. I calculated in the calculator, so the answer will be p of k equals 3 equals 0.0126. You have to try to use E on the calculator before going to the exam. Don't use it for the first time in the exam. Usually you will find the E in the calculator on the button called len, but it is on the top of it, E power something. So you have to click shift and the len button, then you will get E. Usually it is on the calculator, okay? It is on the top right of the buttons, okay? Not the most top, but a little bit second line, I think. The third line of the button from the top right, okay? Using the same principle which we have used also in the binomial also, we have the same thing for question. At least 3. At least 3 alpino means 3. So 3 included in this case. At least 3 means 3 included, 4, 5, 6 up to infinity. So I cannot count all this, get the probability of all these numbers. So I have to take the items which is not included. So at least 3, 4, 5, 6, and so on. So I don't want all this. I use 2, 1, and 0. So I need to get the probability of this 3. Then I said 1 minus the probability of k equals 0 plus the probability of k equals 1 plus the probability of k equals 2. That's it. Get the 3 probability of this and 1 minus them. So I'll get the probability if it's at least 3. Okay? K greater than or equal to 3. This means at least, okay? So I think now it is clear. So let us answer it. So I have to use Poisson formula 3 times for every one of them and then 1 minus the total. So we have already calculated lambda in the previous example, in the part A of the question, okay? We have calculated A, which is NP, it was equal 0.5. I just wrote the formula here, so probability of any k equal lambda, okay? And E power minus lambda, then put k factorial. The way I told you how to memorize it, it's up to you. At the end of the day, you have to write this formula. Then we have to substitute to if the k equals 0 and lambda equal half, so it will be half, okay, divided k 0 factorial and the power k, which is 0, okay, E minus lambda half. The second one will be the same thing, so 0.5 power k1 1 factorial E of power minus half, okay? So this term will remain the same in all the questions, okay? The third one will be just to leave a space. I put them here and there to just leave a space, okay, for calculation. So here it will be 0.5, okay, power 2, okay, divided 2 factorial, E power minus. You have to try the factorial also in the calculator before going to the exam. So I get the probability of all of them. So then I add the probability of k equals 0 plus probability of k equals 1 plus the probability of k equals 2 and add them up. And then so here the probability of k equals 0 plus k equals 1 plus k equals 3. I have to add all the 3 probabilities, okay, which I have got. Add them together, the answer will be 0.986. So the probability of k greater than 3, because it's at least 3, at least means 3, 4, 5, 6, so equals 3 or more, it will be 1 minus the total of the probability of the opposite, okay? So it will be 1 minus 0.986 equals 0.14, which is this one. So the answer here that the probability that the number of albino person at least 3 of a population of 10,000 people is 0.014, which is 1.4% if you want to type it as a percentage, okay? So this is another example, another scenario of Poisson. Poisson, we said that we use it when we have very small probability is very small, and very large n, okay, population. So in this case, we will multiply them and we get lambda equal np. So we can use lambda instead of using n and p. This is called Poisson distribution. The other case we can use Poisson is the interval, because you may have a huge number of people but in a short period, and may have bigger number of people, okay, so the frequency is less, but they are coming for a long distribution. For example, I have 2 people comes for every 1 hour for 10 hours. So after 10 hours, I have 20 people. But in other hospital, I have 7 patients came in 1 hour and no one came in the rest of the day. So 2 patients came every hour, okay, over 10 hours, 20, more than 7 patients came in 1 hour. So if someone look on a spot to them, they will say the hospital who has 7 patients in 1 hour, they have more patients than the other hospital, because they got 7, but they got 7 for short interval only and stop. But if the distribution, I have small frequency, which is 2 only, but over 10 hours they are continuously coming, this also the number of patients during this period will be 20, which will be higher than 7 comes in 1 hour and the rest of the day no one came. So if the matter related to the interval of the time per day, per hour, per week, per 10 minutes, per 15 minutes, every 3 hours, every 2 hours, automatically it will trigger in your mind that this is Poisson distribution. So Poisson distribution, how to know it is Poisson? And we will use the formula of Poisson distribution. Poisson distribution has 2 things. Either you have very low probability and very high population, okay, or the sample size, or you have the interval. This problem about the interval. So he said here that the mean number of patients arriving at emergency room at the university hospital on Saturday nights between 10 to 12, 2 hours interval. So he give me time interval, so it is Poisson problem. Is 6.5. This is the mean number. It is not the number. We don't have people half or quarter. A number of people must be full or integer, but the mean could be fraction, could be decimal, could be anything. Okay, so the mean number is 6.5. Okay, so the mean in the case of Poisson, it is not x bar. The mean in the case of Poisson, it is lambda. So he gave me lambda directly, not NP, because in this case I don't have NP. He gave me lambda directly. It is an interval problem, okay? So lambda equals 6.5. So I got lambda. For Poisson, I need only 2 things, lambda and k. So what is the k? So I can solve the problem. So he assuming that the patient arrived randomly and independently, because it must be independently. If one of them came, it doesn't mean that we don't have any other patient will come, okay? Patients are coming from different areas. So what is the probability that on the given Saturday night, the same night, exactly 2 patients arrive, exactly 2. So k equals exactly 2, not more than, not less than, not at least, exactly 2, okay? Exactly 2 patients arrive at the emergency room in 2 hours interval, the same 2 hours, between 10 and 12, the same 2 hours, between 10 and... So what I can do here, I just have lambda and k, I just write the row. So the probability of k equals 2 equals, I had lambda divided e to power minus lambda, k factorial, that's it. And let me substitute, lambda equals 6.5 power 2 factorial, e to power minus lambda, which is 6.5, calculate them, the answer will be 0.0. So the probability will be 3.2% or 0.32. Okay, so this is the probability. It is a straightforward problem, but we have to know that the interval problem is covered under Poisson's distribution. The second question is now became our favorite or repetitive question. The repetitive question which we have here, that the number of the patient arriving to the emergency in 2 hours interval between 10 to 12 is less than or equal to 2. So it could be the patient k could be equal 2 or 1, less than 1 or 0. These are the 3. So I have to get the probability. Here is straightforward. You get the 3 probability and add them up. It is not 1 minus, because he did not say more than 2. He said he wants that the patient are less than or equal to 2. Less than 2 or equal to, so 2, 1, and 0. So I'll get the probability K equals 2. The probability K equals 1. Probability K equals 0. The 3 probabilities and add them up. So here he wrote them down here. The probability of K equals 0, probability of K equal 1, probability of K equal, and he substitute them here in the formula. So lambda 6.5, which we have. What is lambda? Okay, lambda 0.575, because K equals 0 power K. Just let me write the law here so you can understand it. So here, first one, lambda, okay, 6.5 or power K, which is 0 in this case, okay, divided 0 factorial, 0 factorial means 1, E or power minus 6.5, which is lambda, plus lambda again or power 1 factorial, okay, E or power minus 6. So you'll find E or power 6, E or power minus 6.5 is repeated every time, okay, it will not be changed, okay. And here 6.5 also will be repeated, only the power and the factorial and the denominator, they will be the same always, okay. So here 0 factorial, 1 factorial, 2 factorial, and the answer will be this answer. So it will be the sum of them directly. So before reading the question number 3, I can guess that it will be more than or equal to or at least one of them. So because this one is straightforward, I can expect that it will be the opposite. Okay, let us read it. The number of patients arriving at emergency room in 1 hour interval. So here it was in 2 hours interval. Here in 1 hour interval between 10 to 11 is more than or equals to 2. More than or equals to 2, what does it mean? More than or equal to 2 means 3, 4, 5, starting from 2. So it's or equals to 2, it will be 2, 3, 4, 5, and so on up to infinity. More than or equals to 2. So I cannot calculate anything which is up to infinity. I can calculate the other way around. So since 2 is included here, so I can strike them through. It will be 1 or 0. The probability of 1 or 0, 1 minus the probability of these 2. So looking at the problem here, as I said, the number of patients arriving at the emergency room, 1 hour interval between 10 and 11. So it is within the same range. So this is applicable to it, okay? Because the probability here or the mean or whatever the value he has taken between 10 to 12. So I can take from 10 to 10:30, from 10 to 12, from 11 to 12, from 10 to 11. Anything within this range, the same rules will be applicable to it because this is covering the whole range, okay? But he changed here 2 things. He changed here the interval, he make it shorter, and he changed in the question, he said more than or equal to 2. More than or equal to, as I said, that it will be 2, 3, 4, 5, up to infinity. I cannot use them, so I say the other way it will be 0 or 1. So I'll get the probability of 0 and the probability of 1 and say 1 minus the sum of this probability. So I'll say the probability of K equals 0 plus the probability of K equals 1. I'll add them up and they'll see 1 minus this probability, okay? So I get the answer. But here there is one point. You remember when I give the example at the beginning of the interval, I said that if I have 2 patients coming over 10 hours, so at the end of the day I'll have 20 people, okay? But if these people came for shorter, 2 people came for 5 hours only, so how many patients I'll have? I'll have only 2 times 5. To the period is shorter, this means the number of patients will be smaller, okay? So n will be half, and if n is b half, lambda equals np. So n will be half, so lambda will be half, okay? So since this was for 2 hours initially, 6.5 lambda equals 6.5 for 2 hours. For 2 hours. So for 1 hour only, the lambda will be equaling half of this, 3.25. Okay, so for 1 hour, the new lambda 1, the new lambda or lambda new would be equal 6.5 divided 2, because this is half of the period. 1 hour, half of the 2 hours. Okay, if it is half of the period, so the number, we assume the number will be half of it. Okay, so the only trick here that it is 1 hour. 1 hour means that I'll have half of the lambda. This is the only trick, and the rest will be the same. So this is lambda new will be 6.5 divided 2 equals 3.25. And then I calculate the probability k equals 0 and the k equal 1 and say 1 minus them. Okay? So the probability, let me write it again. Minus 3.25. Okay. And here, lambda, which is 3.25. Power 0, 0 factorial, 3.25 power 1 factorial. So I'll get the answer of these two. Okay, then I'll get the answer of these two and I'll sum them up. Okay, so the answer will be plus probability of k equals 1 will be equaling 0.165. Okay, this is the probability. So the probability of k greater than or equal to 2, it will be equal 1 minus 0.165, which will be equaling to 0.835. Okay, this is the answer. I hope it's clear also, and it is simple. The only trick was the interval. In this problem, we introduced a gene of fluorescent protein into cells so we can investigate the subcellular localization of this protein. Okay, the transfection efficiency is 1%. This is the efficiency, is the probability. So the probability here will be 0.011%. Okay, it will be 1%. The average number of usually there are 100 cells. So you may find this number repeated every time of this fluorescent equation, because usually they're using this 100 cell and the efficiency within the range of 1%. Okay. So even the numbers might be repeated if the same problem came in the exam. So n equals 100, okay, and the efficiency is 0.01. So I can notice that the n is large, but is not so large. It is moderate. Also, the probability is not so small. It is 0.01, small, but not so small. So here I can use both of the distributions ways. So I can use the binomial and I can use the Poisson distribution. Okay, so I can use any of them. I have n and p, so I can get lambda. Np, I can get lambda. Lambda will be equaling 0.01 times 100 equals 1. Okay, so this will be my lambda. So I need k. K is given to me as 3. He said, what is the probability that the microscope will be so likely? At least 3. Oh, he did not give me 3. He said at least 3. So it could be 3, 4, 5, 6, 7. So at least 3, 4, 5, 6, 7. So now it's more complicated. I cannot take them. So I'll take 2, 1, and 0 only. The 3 probability. Then I'll add them up and 1 minus their probability. Okay. Probability of k equals 0. Probability of k equals 1. Probability of k equals 2. Okay. So I can use this way and find it using lambda Poisson equation, and I can use the binomial because binomial require PQ. So if this is the P, the Q will be 0.99. Okay, so I have PQ, I have NK, so I can use the two ways. But in all the 3 scenarios, I have to repeat the experiment 3 times because he said at least 3. So I have to calculate for 2, for 1, and 0, and then add them up and minusing from 1. Since we have repeated these questions many times, so just I'm going to read quickly. First of all, he will use the binomial. Binomial, he has to get the Q, so we have already calculated the P and the Q. So the probability of K equals 0. Now we know why we are getting 0 and 1 and 2, because we cannot get up to infinity, okay? So we strike it through and get the remaining, and 1 minus the sum of their probability. So probability of K equals 0, we'll use the binomial, which is n factorial divided n minus k factorial, and so on, p o power k, q o power n minus k, the rule, okay? And we'll calculate it here for k equal 0, k equal 1, k equal 2, and we'll add them up, okay? And we'll say 1 minus the total of them, okay? So this will be the sum of them. So the answer will be 0.020610. This will be the answer, the sum of them. So the probability of k greater than 3 will be 1 minus 0.92061 equals 0.7 939. This is the probability. Okay, the same number here. Okay, so the probability of getting k greater than or equal to 3, this will be the answer. This using binomial. Okay, if we try the same thing here using Poisson distribution, so we have also to get the same thing. The probability when k equals 0, probability when k equals 1, probability when k equals 2. So it will be, the total will be 0.91954. This is the probability of this 3. So the probability of k equals 1 minus 0.91954 equals 0.08046. So the two probabilities here, using Poisson and using binomial, is closer. Here 8% and here 7.9%. Okay, so this one 7.9% and this one 8.04%. They are very close. Okay, in this case maybe the binomial would be more accurate because Poisson has condition that b must be very small and then must be very big, and here the numbers are moderate, they are not so small and so big. So binomial maybe it's more accurate, but they are very close to each other. Okay, with Poisson it is 0.804% and with binomial it is 7.94. Okay, so approximately both of them are the same, and approximately the binomial with the Poisson was good, both of them. This problem is almost same as the previous one. The chance that someone suffers from an adverse reaction from a dangerous medical treatment is 0.4. So this is the probability, is 0.4. What is the probability that in a sample of, so this is the n, the number of the individual in the sample, okay? And here dangerous medical treatment is 0.4. So 0.4 is the probability. So I can automatically calculate the Q, which is 0.6, the complementary. If B equals 0.4, Q equals 0.6. So N here in this case 5. So what is the K? K will be the problem here. He will give me 2 Ks. So at least 2. Okay, what is the probability? At least 2 suffer from adverse. So K at least 2 means equals 2 or greater than 2. Okay, this is what I'm looking for. So at least 2 means 2. This is the way to understand and avoid any mistakes. I used to write this. At least 2 to 2, 3, 4, 5 up to infinity. So I subtracted them through, then I write 1 and 0. So I have to get the probability of 1 and 0 and then say 1 minus the sum of the probability k equals 0 plus probability of k equals 1. Add these two probability and minus them from 1. I can get them because here the probability is very big, also it's not small. So the probability is 0.4. It's not a small one. And the sample is small, it is n. So I can solve it using binomial, which is the correct one. If I try to use the by Poisson, okay, so here once I get the result, I can calculate them using Poisson and I calculate using binomial. But I found that Poisson in this case, it will not work as good as binomial because this is actually mainly binomial problem. Binomial problem, I can Poisson will be helpful and accurate in the case of I have large number sample, very large. Even the probability is very minor, very small. It is unlikely to happen or less likely to happen. But if I have large sample, but the sample here is only 5. So once I calculate, I notice that the Poisson percentage or the Poisson probability is small or not accurate compared to the binomial. So here using the binomial, I have n equals 5, k. In this case, k will be equaling 0 and 1. One time I'll calculate for 0 and the other time I'll calculate for 1. Okay. And then I say 1 minus, so the probability is 0.4. The complementary, okay, of not having the bad reaction. So the probability of bad reaction, 0.4. Okay, dangerous reaction. The probability of not having the dangerous reaction, 0.6, the complementary one. Then I can use the binomial, okay? Binomial law for this NCR, if you remember. Okay, so I say n factorial divided n minus k factorial p of power k q of n minus k. Okay, and put k first time, probability of k equals 0. And second time put k equals 1 and I find the answer. So this will be the answer for using the binomial. Okay, so this is with binomial. This is the answer, 66.3%. If I use Poisson, I just need lambda. So lambda, I have p and then, okay, so n times p will be equaling to 5 times 0.4 equals 2. So I have lambda already. I have k, which is one time will be 1, 0, and the other time will be 1. Okay, so I get the answer of them. Okay, so, and when I subtract them, I get 1 minus the probability. Okay, so the answer will be 59%. So in this question, in this example, only the problem is in the calculation. Here a solution. The solution of 1 deciliter. Dc, if you remember, when we said that 1 decimeter equal 10 centimeter. The word dc means tens, okay, decimeter. So 1 decimeter equals, with respect to the meter, equals 0.1 meter. Okay, divided 10, okay, like, but millimeter, 0.001 meter. 1 milli. 1 millimeter equals 0.00 meter, but 1 decimeter equal only 0.1. Sorry for writing. Okay, so 1 decimeter equal 0.1 meter. So in the same way here, 1 deciliter equals 0.1 liter. Okay, 1 microliter equal micro means 10 to the power minus 6, 10 to the power minus 6 liter. Okay, so the point only here is the calculation. So here a solution of 1 deciliter contaminated with 3 times 10 to the power 5 bacteria. So I have huge number of bacteria. N is huge number. N is a very big sample. Okay, 10 to the power 5 bacteria. So this is N. Sorry, it's 3, not 5. 3 times 10 to the power 5 bacteria. So this is my N. Okay, so I know since it is a huge or a big N, we may be using Poisson distribution. Okay, so in order to use Poisson, I need N and P to get lambda. Then I need K, because I need only lambda and K. In order to get lambda, I need P and N and P. I have already N, so I need P. What is the probability? The probability here, actually, it's coming from the percentage he has taken from the solution. So he has a solution of 1 deciliter. 1 deciliter means 0.1 liter. Okay? And they have taken a small sample, the sample of 1 microliter. 1 microliter means 1 times 10 of power minus 6. Okay, liter. Or 10 power minus 6 liter. Okay, so the sample here, the probability or the percentage is the sample which he has taken 1 microliter divided 1 deciliter. So let us convert them into liter in order to get the percentage or the fraction. Okay, 1 micro means 10 to the power minus 6 liter. 1 decimeter means 0.1 liter. Okay, so it will be 10 to the power minus 6 divided 10 to the power minus 1. So I can get this one up, so it will be equal to 10 to the power minus 5. Okay, 10 to the power minus 5. So this is the probability, very, very small. So P will be equal to 10 to the power minus 5. So now I can say that, okay, my N is 3 times 10 to the power 5, which is very big, very large number. My P is 10 to the power minus 5, which is very, very small. So it is a clear case of Poisson distribution. Okay, so here the question, what is the probability that at least one bacterium, at least one means 1, 2, 3, 4, and so on. So I can get at least one means 1, 2, 3, 4 up to infinity. So I cannot calculate up to infinity. So I get the opposite, that I strike them through. The only option remaining here is 0. So the probability that K equals 0, and I'll say 1 minus it. Okay, so I'll use Poisson to do this calculation. So I have n and p. So what lambda will be? Lambda will be np. Okay, right? Lambda will be np. It will be equal 3 times 10 to the power minus 5, 10 to the power 5 times 10 to the power minus 5. They will cancel each other. So lambda will be equaling 3. So I can clear all the page now. And I can say in my problem, I have lambda equals 3. And I have k equals 0, but I want the reverse. Okay, so I'm looking for the property that k, at least one bacterium k greater than or equal to 0, 1. So, which is 1, 2, 3, 4, and so on up to infinity. I don't want them. I want k equals 0, and then I say 1 minus. Okay, 1 minus the probability of this k. Okay. So I have to get the probability of k equals 0 using a Poisson formula. So Poisson said that lambda e of minus lambda k factorial. This is the probability of k. Okay. So just I have to substitute. Lambda equals 3 and the k equals 0 divided k equals 0 e of power minus 3. So 0 factorial means 1, and this 1 divided 1 equals 1. So it will be e of power minus 3, which will be equal to 0.04979. So this is the probability of k equal 0. I want the reverse, so it will be 1 minus 0.04979 equals 0.9502. Okay, this will be my answer. Okay, so this will be the probability. Okay, here he gave me more than one way how to calculate the formula. Even using binomial we can get it. And if you notice here, we can get it using this is only different way how to calculate the lambda, because only the trick here how to calculate the lambda. So I have 3 methods how to calculate the lambda, and I found this one is the best one, just to understand that he has taken a smaller sample of a big sample, and this sample has the bacteria. So the proportion between this small sample and the big sample, this will be the point. So you can get without going to the density and this complication. So just to get the probability, the ratio between the quantity of the solution, the sample which he has taken, to the total quantity which has the bacteria. So the percentage between them, or the fraction, it will be giving me the probability. Then probability p. Then I multiply n times p. I'll get lambda, and the whole solution will the whole solution steps will be very easy. We'll follow the Poisson distribution steps, and it will be easy. And also here in the next slide, he has calculated using binomial as well, because also he has p now. The probability, he has the probability which we just calculated. So if he got the probability, although it is very small and n very big, so but still he can use the probability. He has p, so he can get q. He has n and he has k as well, so he can use the binomial. And the answer here was 0.950213, and the answer here in the binomial was 0.90214. So it's very close to them. Okay, binomial is the base. Just keep in mind, binomial is the base, and the Poisson is exception. Okay. Thank you very much. By here we reach the end of seminar 4.